So the first system message reception, which could be done by the user, is the MIB, which is being sent once in a radio frame, once in a 10 millisecond. So MIB is carried by physical broadcast channel, which is the blue color. So we can see that physical broadcast channel occupy 4 symbols time. 1, 2, 3, 4, 4 symbols right after synchronization signal. So right after synchronization signal, MIB will be sent, and it occupies 6 resource block in the frequency domain. So 6 resource block, which is equivalent to 72 subcarriers in the frequency domain. So MIB carries the first information is called downlink bandwidth, where the number of the resource block is carried by MIB. The user has to decode this information in order to know at which extent that the user has to extend the receiver range. And the second information is the configuration of the HARQ feedback channel, which is PHICH. And the third information is the system frame number, SFN, of the particular radio frame. We should know that in LTE, every radio frame is being assigned with one SFN, where the list of the range of the SFN starts from 0 and it ends at 1023. So after the decoding of the MIB, the user has to decode the most important SIPs. There are a total of 13 SIPs, where SIP1 and SIP2 are mandatory. SIP1 carry all information about cell selection and cell cam related parameters, where the most important information carried by SIP1 is the PLMN tag. So the user has to decode SIP1 in order to compare the PLMN tag carried by SIP1, compare it with the one decoded in the SIM card. So this is to check if the user came on the appropriate network or not. SIP2 carry basic radio parameters, where all of the information of uplink bandwidth, uplink channels, and all of the information of downlink channels, they are all carried by SIP2. SIP3 carry the common parameters for user to perform cell reselection. SIP4, 5, 6, 7, and 8 carries the neighbor list for reselection, which it could include intra-frequency neighbor list, inter-frequency, UMTS, GSM, and CDMA 2000 neighbor list. SIP9 is for the home INB information. SIP10 and 11, they are for earthquake and tsunami warning system, where SIP12 and SIP13 are for CMAS notification and multimedia broadcast multicast service control information. So the user has decoded the SIPs, and a user has to proceed in measure the reference signal strength of the cell. So the user has to measure the power strength which is delivered or which is sent in the form of reference signal, and then to obtain the result, which is called RSRP and RSRQ. So the user needs to do that, as the user has to decide if the current cam cell is it appropriate or suitable to be cam on based on cell selection criteria. So in this example, there are 3 candidate cells here. The user has to choose one best cell to cam on based on the formula. So the criteria for cell selection simply means the SRS level has to be greater than 0 and S qual to be greater than 0. So the whole equation here has to be greater than 0. That means the measured RSRP it has to be greater than the minimum requirement with the minimum offset with P compensation. So is the RSRQ, where the measured RSRQ has to be greater than the minimum requirement with the Q qual mean offset. So the Q qual mean offset and QRS level mean offset is usually set at 0. It is only used when the mobile phone is currently not in the home PLMN. So the user will perform periodical searching for a higher priority PLMN. So this is only for the user who are not at the home and trying to search for a higher priority PRMN to camp on. In other cases, they are usually set at 0. P compensation is only for the terminal where the maximum transmit power is lower than the network setting, which is usually set at 23 dBm. Hence, if the terminal is having a maximum transmit power lower than 23 dBm, then the user is imposed the difference as the P compensation. For example, if the mobile phone is having 21 dBm of the maximum transmit power, then the P compensation equals to 23 dBm minus 21 dBm, which is 2 dB of the P compensation. So that is the whole procedure right from the mobile phone turn on and to select a PRMN and eventually to settle on a cell, which is to camp on a cell. After the user performs cell selection, then the user might move from one location to another location. Hence, the user has to perform cell reselection. Cell reselection is a process where it's considered as the mobility management in the idle mode. So the process includes 2 stages. Stage number 1, that is the criteria to start a measurement, and criteria number 2, that's stage number 2, which is to perform cell reselection. Before having a look on the parameters of these 2 stages, so we have to introduce that there is a parameter which is called frequency priority for each frequency. So if the measurement is about intra-frequency neighbor, then the priority is the same between the source cell and the candidate cell, so the priority would be ignored. As for interfrequency and IRAD neighbor measurement, then there is difference of the priority. So the user has to consider the priority between the source cells and the neighbor cells. Let's start with the intra-frequency cell reselection. So we have mentioned earlier there are 2 stages. Stage 1, that is to start the measurement. So for intra-frequency measurement criteria, if the measurement trigger threshold is not configured, then the user always perform intra-frequency measurement. In another hand, if the intra-frequency measurement triggering threshold is configured, then the user has to judge if the user should perform intra-frequency measurement or not according to the criteria mentioned here. So if SRX level is greater than S intra search and S quad is greater than S intra search Q, which is the RSRQ, then the user does not perform the frequency measurement. But if the SRS level is smaller than the threshold or the S quad, which is the RSRQ, is smaller than the threshold, then the user has to perform measurement. So what is the meaning of SRS level? That has been explained earlier in the previous page. So SRX level equals to the measured value of the RSRP minus the minimum requirement, and offset, which is usually 0, and the P compensation, which we can assume it to be 0. So that means the user will start measuring if the QRS level minus QRS level mean is smaller than the measurement start triggering threshold. That means the user will start measuring when the measured RSRP is very close to the minimum requirement. QRX level measured minus QRX level minimum smaller than a threshold. So the user has been detecting that the measured RSRP is very close to the minimum requirement. Hence, the user would like to start intra-frequency measurement. As for interfrequency and IRAD measurement criteria, then this is the scenario where we have to consider the frequency priority. So for the neighbor with higher priority, then the user always have to measure the neighbor because the neighbor has been defined with higher priority. If the neighbor has been defined with lower or equal frequency priority, then it's similar to intra-frequency measurement. It's similar where it depends if the measurement start threshold is defined or not. If it is not defined, then the user always perform intra-frequency and IRAD measurement. If the threshold is defined, then the user has to check again if the measured RSRP minus the minimum requirement, if it is smaller than the threshold, or the measured RSRQ minus the minimum RSRQ is smaller than the threshold, then the user will start measuring interfrequency or IRAD neighbor. So we have seen the measurement start criteria. Now, this is about whether the user should perform reselection or not. So again, we are looking at two scenarios here. Scenario number one, that is for intra-frequency cell reselection, or if the neighbor is having exactly the same equal priority. So then the user will only perform reselection if Rn is greater than Rs for some time. Rn equals to the measured RSRP minus the cell offset. Rs equals to the measured of the RSRP of the serving cell plus hysteresis. So when the neighbor is greater than serving, then the user will perform reselection. Scenario number two, that is when the neighbor cell is having higher priority. If the neighbor is having higher priority, then the user will perform reselection regardless of the RSRP of the serving cell. It is not being considered. User will only consider the measured value of the higher priority cell. If it is, that is Q qua measured minus Q qua mean greater than a threshold. So as long as the measured RSRQ or ECIO minus the minimum requirement is greater than a threshold, a cell reselection criteria, the user will reselect to the candidate cell. Same goes for RSRP. So if the measured RSRP minus the minimum requirement and P compensation is greater than the threshold, the user will be reselect to the candidate cell. In contrast, if the neighbor cell is having low priority, then user will only reselect to the low priority neighbor cell when the serving cell is lower than the S equals S, which is the serving cell, is lower than the threshold. That means the measured RSRQ of the serving cell minus minimum requirement is lower than the threshold. At the same time, the RSRQ measured for the neighbor minus the minimum requirement is better than another threshold. Then the user will reselect to a low priority neighbor cell. That's the same if we use RSRP, where the serving RSRP minus the minimum requirement is lower than a threshold. At the same time, the measured RSRP of the candidate cell is better than a threshold. So this is the criteria and the stages for cell reselection, which include measurement start criteria and reselection criteria.